Have you ever really stopped to think about the ground beneath your feet? I mean, not just the pavement, but the colossal, powerful forces constantly grinding and shifting deep within our planet. We're talking about forces that can literally build mountains from scratch and unleash some of the most powerful events in nature. They're at work right now, reshaping our world. Okay, so let's start with a fact that might just change how you see the world. The solid, stable ground we all take for granted? Well, it's not really solid at all. It's actually a collection of massive, rigid plates that are constantly under incredible stress, bending, breaking, and sliding in this epic slow-motion dance that plays out over millions of years. So, we're going to take a journey deep into the Earth's crust. We're going to explore how the exact same forces that sculpt these breathtaking mountain ranges can also trigger the planet's most destructive events. It's this amazing story of creation and destruction, all powered by our restless Earth. And let's start with the destructive side. Just look at this number, 9.1. That's the staggering magnitude of the 2004 earthquake in Sumatra. Now, this wasn't just a tremor. This was a violent, sudden rupture in the Earth's crust that unleashed a catastrophic tsunami. It's a terrifying reminder of the raw power that's just waiting to be released from beneath our feet. But here's the flip side. That same incredible energy isn't just about destruction, it's also a powerful creative force. This quote here really nails it. You've got the Indian plate relentlessly smashing into the Asian plate, while that considerable net resistance is the engine that builds mountains. Over millions of years, that immense pressure has literally crumpled the crust to form the Himalayas, the highest mountain range on the entire planet. So you've got this one process that can cause both sudden, violent destruction and slow, majestic creation. What's the common thread? What's the geological feature responsible for both? The answer is simple yet profound. They're fractures in the Earth's crust where things have moved. We call them faults. All right, let's break this down. To really get a handle on how these things work, we need to learn a little bit of the language of geology. We're going to look at the anatomy of these massive cracks in the Earth. Everything, and I mean everything, starts with stress. You've got these tectonic plates that are always on the move, and that creates constant pushing, pulling, and sliding forces on the rock. Geologists call this force, spread out over an area, stress. It's the pressure that just builds and builds and builds. Now, every rock has its breaking point. When that stress becomes too much for the rock to handle, it snaps, it fractures. But here's the key. A fault isn't just any old crack. It's a crack where the two blocks of rock on either side have actually moved past each other. That movement is what makes it a fault. So to figure out what's going on, geologists look at the geometry. They measure the angle of that break, that's the dip, and the direction it runs across the land, that's the strike. But the most important part, they measure the slip. That's how far the two sides have actually moved. All these little details tell the bigger story of the incredible forces at play. Okay, so how does this movement actually happen? Well, it all comes down to the direction of the stress. Is the crust being pulled apart, squeezed together, or are the blocks just sliding past each other? That gives us three main types of faults, and each one tells a completely different story. First up, we have normal faults. This is what you get when the Earth's crust is being stretched apart by what we call tensional forces. As it pulls apart, the block of rock on one side of the fault just slides down. The Earth is literally opening up. And that stretching and dropping motion is exactly how we get massive rift valleys. You've probably heard of the East African Rift Valley. That's a place where a whole continent is actively being torn apart. It's incredible. But what happens when you do the opposite, when you squeeze the crust together instead of pulling it apart? Well, that compressional force gives you what are called thrust faults or reverse faults. In this case, instead of one side dropping down, it gets forced up and over the other block. And this right here is how you build mountains. That colossal squeezing force drives these huge slabs of rock upward, stacking them on top of each other and creating the absolute titans of our planet, like the Himalayas. And then you have the third way. This is when the blocks aren't moving up or down relative to each other, but are grinding past one another horizontally. The force is called shear. A perfect way to picture this? Imagine pushing the top half of a deck of cards sideways. That's a strike-slip fault. Of course, the most famous example on the planet has to be the San Andreas Fault out in California. It's this massive strike-slip fault where two giant tectonic plates are just sliding past each other, building up all that tension we hear so much about. So here's the big takeaway. When you hear the word fault, you probably think earthquake. And you're not wrong, but their importance goes so much deeper than just destruction. They are absolutely fundamental to our economy and even our environment. I mean, just look at how this breaks down. Yeah, there's a huge academic interest, of course, but look at the economic, societal, and environmental impacts. These things affect our lives in ways you might never expect. And here's why. Think of faults as the Earth's natural plumbing system. These fractures create pathways. Sometimes those pathways allow fluids rich in minerals like gold and copper to flow up from deep within the Earth. Other times, they create traps that hold on to huge reserves of oil and natural gas. They even control where we find groundwater. It's amazing. And the scale of movement we're talking about here is just, well, it's mind-boggling. Get this. Geologists estimate that along one of the big thrust faults in the Himalayas, huge chunks of rock have been shoved about 80 kilometers from where they started. That's like picking up a mountain range and moving it to the next state over. Absolutely wild. All of this just goes to show that our planet is not some static rock floating in space. It is a living, breathing, dynamic system. The very same forces that built the mountains we see today and trap the resources we rely on are still hard at work, which leaves us with a pretty cool question to think about. Since the plates are always moving, where on Earth, right now, is the next great mountain range quietly being born?